Hello everyone, welcome to IIT and GATE classes. This is lecture 8 on operating system, and in the previous lecture we were discussing about system calls related to process creation. The very first call was fork system call, and fork system call is used to create the child process. Okay, and clone of the parent is created, okay, somewhere else in the main memory, and both parent and child run concurrently. These are very important point which I have told you. Okay, so let me revise it. Okay, so basically what fork will do, see, this is the parent process. So as soon as parent do a fork system call, immediately its clone will be created anywhere else in the main memory. See, this is the parent process address space. So entire parent will be copied somewhere else in the main memory, or you can say entire parent code is copied in main memory somewhere else. Okay, and that will be called as child process. And after doing fork system call, both parent and child will run concurrently. Okay, parent will also run, child will also run, like this. Okay, please take snapshot. I will jump to the next slide now. Okay. So next system call was exit system call. Exit system call is used to terminate the process. I think I have told you in the previous lecture itself. I'm just revising it so that you get more clarity, because now I am going to start a program. Okay, few programs I will return which have been asked in many competitive exams. So before that, I'm just revising. Okay, yes. So exit is used to terminate the process. Wait, parent will do the wait system call. Okay, first of all, you should remember who will do the wait system call. Parent will do the wait system call, and it is used to put the parent process in wait state till one of its child process terminate. Okay, you have to remember this thing. Maybe there may be chance that parent has created many childs. Okay, c1, c2, c3, c4, and so on. So even if one of the child terminate na, then parent will start. That is the basic meaning of wait system call. Okay, so it is used to put parent process in wait state till one of its child terminate. Okay, next is exec system call. Exec system call, I have told you, say parent or child can do exec system call. Wait can be done by only parent, but exec can be done by either parent or child. And by doing exec, parent process address space is overwritten by some other process code. Okay, sorry, parent a process address space. Okay, parent or child can do exec system call, and by doing exec system call, process address space. Okay, process address space is overwritten by some other process code, and parent and child relationship is broken. I have told you real life examples in the previous lecture also. See, this is a parent, and let us suppose, yeah, this is the scenario I have told you in the previous lecture. Now, this is the parent process. Okay, so whenever for system call is done, copy will be created, and the child process will be created. Clone, they will be child will be exact clone of the parent, because entire code will be copy pasted. And now suppose child has done exact system call. So whatever address is written in the exact, okay, so for example, some code has been address of the code has been written, so that from that address code will be copy pasted here itself. Okay, so child process code or child process code will be overwritten by this file. So now, since parent and child have different codes, so their relationship will be broken. Okay, so now parent and child relationship is broken. Okay, I hope I have made the point clear. So like this, na, if child is not behaving like what parent is saying, so obviously parent will say na that you are not my child, and so on. Somewhere some fights and all happen between parent and child, just because child is saying that I want to do this thing, and parent is saying no, you should not do these kind of things, and so on. So immediately when child keep on saying like this, that I will do it, I will do it, and when he finally do, and then parent will say, okay, now you are not my child, and so on. So that is the scenario here. Okay, for example, you can think of intercaste marriage and so on. Whatever example you want, you can take. So whenever child is behaving himself that I want to do this thing and all, and in spite of refusing, child is keep on doing the things, then parent will say, okay, you are not my child. Okay, similarly, so in this scenario, this was the real life scenario, but in case of operating system, parent can also do this thing. So whenever parent do exec system call, then also parent and child relationship will be broken. Okay, like a child is saying that a child is saying to the parent that you should not do these kinds of things and all, and parent keep on doing and so on. So now their relationship will be broken, because child will get hurt that why my parents are not doing these kinds of things and so on. So you can take any examples. I'm not going into details of that. You can think of any real life example yourself. Okay, so the main thing is either parent or child can do exact system call, and by doing that, their parent child relationship will be broken. So whoever do the exact system call, their relationship will be broken. Either parent do exact system call or child do parent exact system call. As soon as they do exact system call, their relationship will be broken. Okay, that's it. Okay, so now please you can take the snapshot. I am jumping to the next slide now. Okay, please take snapshot. I think everything, yeah. Now everything is on one slide. Take snapshot. I'm jumping to the next slide. And now I'm going to explain you small programs. Okay, regarding these system calls, I will explain them in the C language because C language is in most of the competitive exam syllabus. I'm jumping to the next slide now. Okay, so let me write a small program in C. Okay, program in C. Okay, so I will write void main. Okay, and in that I'm writing int PID. PID means the process ID of the process, and it is an integer quantity. Now PID is equal to fork. So this is the for system call. So as soon as for system call is done, so child will be created. So now see this void main PID and so on. This is a program. This is a piece of code. So whenever it will start execution, it will become a process. So we call it as a parent process. Now this parent has done a for system call. So as soon as it has done for system call, its copy will be created in the main memory. That means clone will be created. That will be known as child process. Okay. So it has done for system call. So now let me write it. If I say if PID double is equal to -1, then what we will say? We will say printf fork unsuccessful. Printf fork unsuccessful. Printf fork unsuccessful, and we will do exit. Exit system call means to exit. That means to terminate the process. We will do this exit system call. Okay, and we can pass any parameters. Let us suppose I pass here 1. So why I'm passing 1 and all, you will understand it later. Okay, let me write it first. Okay, exit, and then we will say else if PID is equal to 0, then I will say printf child. Okay, and again we will say exit, and let me say here exit 2. Okay, yes, and after that we will say else I will say printf parent. Okay, and I will say exit 3. Okay, yes, so finally I will terminate the program. Now let me put everything on one slide so that you can see it. Okay, so yeah, this is the program which I have written. So now let me explain it word by word. Okay, so void main int PID. So PID has been created. So let me draw it. Okay, so in the main memory, this is the main memory. So in the main memory, since I have written this code, okay, and when it will start running, it will become process. So let me say that this is the parent process. Let me label it as P1. Okay, so now what in the code what we have done in PID. So I will allocate say 2 bytes of memory. I am assuming integer is taking 2 bytes. So PID it has been created. Okay, so memory for 2-byte memory for this PID variable has been created. Okay, so now what I'm saying, PID is equal to fork. The moment parent process do the fork system call, immediately its clone will be created in the main memory. So let us suppose its clone is created here as it is. Each and every line of code will be copied from here to here as it is. Okay, so obviously the child process will also have this PID. Okay, see this PID now. So it will also have PID. So let me write it. PID. Are you able to see it? PID. Okay, now it's visible. Okay, so now this is PID and this is also PID. So both parent and child are having their own variable, 2-byte variable PID. I'm assuming 2 byte for integer. You can assume 4 bytes and so on. It entirely depends on compiler to compiler of the C language. Okay, compiler and operating system both will decide the memory allocated for variable and so on. I'm not going into details of all these things because you have studied that in C language. Okay, yes. So next is, so PID is equal to fork. Now see what exactly. See, I have written a PID is equal to fork. That means what? Fork system call. You can think just like it is a function. So a function will return some value. So more precisely, I will say that the system call will return some value to this PID. So what it will return, you have to see carefully. See, if PID double is equal to -1, then I will say fork is unsuccessful. So in Unix environment or in most of the operating system, whenever system call return -1, that means that system call has not been executed properly. Okay, so -1 means system call, for system call not executed properly. Not executed. Okay, why it has not executed properly? Because there are many reasons for it. For example, there are basically two main reasons. The first reason is the parent process. There is a limit in Unix operating system that how many child a parent can create. So if that limit has been over, so obviously fork will return -1. So like I can say parent can produce 20 child. So if it has produced 20 child, then after that, whenever parent try to produce a 21st child, it will show error message, or you can say it will return -1. Okay, so when fork will return -1, there is a limit now. So limit exceeded. Let me write it properly. So two reasons. Okay, so where should I write? Okay, I'm writing here. So let me write it. Two reasons. There are two reasons for this. Okay, so first reason is limit exceed. So there is a limit. That limit has been exceeded. Okay. Yes. Next, and it entirely depends on implementation to implementation. That's why I'm not showing you the exact limit and all. I think you have guessed it. It entirely depends on implementation. Okay. And the next is we can suppose that since we are creating clone of the parent, so there might so we clone, that means the child also needs some processor address space or some memory in RAM. So if RAM is not available, then obviously it will not be created. Okay. So next is RAM not available or memory not available. Let me write it properly. Memory not available. Memory not available. So when memory is not available, immediately it will show error message. I hope I have made the point clear. Okay, so two reasons for fork returning -1. Okay, so first of all, I'm checking that thing. If PID is equal to -1, that means a fork will be unsuccessful. Exit means now parent process will be terminated. Okay, so I'm assuming that PID has not returned -1, it has returned something else. So because if has not been executed, so we will jump to else if. Now else if PID double is equal to 0. So now this thing you have to remember. See, both parent and child are having PID variable. So PID of the child will contain value 0. Okay, and PID of the parent will contain PID of the child which has been created. Okay, so a PID variable in the parent process will contain the process ID of the child which has just been created. For example, process ID of the child is say 10. So I will write here 10. Are you getting it? So whenever parent process create a child process, then PID of the parent, PID variable of the parent, or you can say simply, I should say fork system call. Let me write it, say like this, so that you do not get confused. Fork system call will return 0 to the child, and fork system call will return process ID of the child to the parent. Are you getting it? Let me write it. So fork, uh, it will return 0 to child, 0 to child, and PID of child to parent. Okay. Well, see, I have told you many times now, every process has its own process ID. And with the help of that process ID, operating system will recognize the process, and that process ID is unique for every process. Now, since child is also a process, so it also has a process ID. Now, do not get confused with PID here. PID is a variable which will store process ID of the PID is a variable which will store process ID. That's it. Okay, so I'm assuming that thing. So now PID is equal to fork means what? So fork will return 0. So PID will contain 0 in child, and this PID variable, please try to focus, this PID variable in the parent, it will hold the value 10. Why 10? I'm assuming that the child process which has been created just now has got process ID 10. Okay, operating system obviously has given the process ID to it, and that is, I'm assuming it is 10. Okay, that's why I have written here 10. I hope I have made the point clear and everything is now fine with everybody. Okay, so PID is equal to fork. We have completed now. So fork will return 0 to the child and PID of child to the parent. Okay, so now finally, if you have got, then it is very simple. So I will say else if PID is equal to 0. So where PID will be 0 for the child. So it will print child and child will be exit, and else printf parent. So obviously else means what? PID is not equal to 0 and PID is not equal to -1. That means what? PID is something. I don't know what will be the exact value. That's why I've written else. Okay, so it will print the parent. Okay, so if you still have any confusion, then let me say it like this. Okay, whenever for system call is done, so a clone has been created in main memory, parent and child both will run concurrently. So what exactly we will show? So assume that this code is for see, same code copy will be for parent also and for child also. So as soon as after doing fork, PID will contain the respective PIDs, whatever may be the case. So now both parent and child, let me show you by a red color or green color. Okay, so now both parent and child will be here, both will be here, so both will execute this thing. Okay, so PID for, let us suppose first parent come and then child come, you can assume anything. So let me take let me clear you one more doubt. We are assuming uniprocessor system. Uniprocessor means only one processor, so only one task can be executed at a time. If you have only one brain, obviously we all have one brain, so we can do only one task at a time. Okay, we may be thinking that we are doing multitasking, but actually we are pausing something. Like for example, you are on a phone call and you are talking to somebody, and side by side you are writing something. So obviously when you are writing something, then you are not listening. You may be thinking that you are listening, but actually you are not listening. Your entire concentration is on writing. And when you are listening, then your entire concentration is on listening. You cannot write at that time. Okay, please try to think about it. If you think deeply, you will get the answer that our brain is one, so we can do only one task at a time. It's all about we are switching between them. I'm listening and I'm writing, I'm listening and I'm writing. That is the basic thing. So same scenario here. So parent and child are running concurrently. That means what? You can think that round robin scheduling is there. So after executing say 2 nanosecond or 3 nanosecond, we will execute child, and then after executing child for 3 nanosecond, we will jump to the parent, and so on. It entirely depends on time quantum and all. So accordingly we will execute. Okay, so uniprocessor, so one task at a time. So let us assume parent come first. So if parent come first, so PID is equal to -1 for unsuccessful exit and so on. It will not be done because PID is not -1 in case of parent. Okay, and then it will jump to the else if code, but let us assume interrupt comes and child process started. So when child process started, it will again do this thing. PID double is equal to -1, printf for unsuccessful and so on. So it will not be able to do this thing because PID of the child is 0. 0 is not equal to -1. So now I am assuming that both are here. Okay, so first I have assumed parent come and then it has executed it, and then I am assuming child come and it has also executed it, and both are now here. So now it's our choice, whatever process we want we can start. Let us suppose child start. So when child start, then what it will do, it will print child. Okay, so PID, obviously PID is 0 now, so it will print child and exit. So output of this program will be child and then it will be exit. Okay, exit means child will be terminated. So obviously now only one process, that is parent, is remaining. So parent will come here and it will check PID is equal to 0. It will say no, 10 is not equal to 0. So obviously this code will be not executed, and else part it will be executed and it will print the parent. And again exit means it will be also terminated. Okay, so child and then parent. This is the scenario. Now another possibility can be, I have assumed that child came first. Let us suppose parent came first. If parent came first, then parent PID is 10. So 10 is equal to 0. No, so it will print parent and it will exit. Okay, so we will print parent. Let me use another color, parent. Okay, yes, and it will be terminated. So now since parent is terminated, so only process left is child. So child will come and child will say PID is equal to 0. PID is equal to 0. Yes, PID is 0. So it will print child and it will be terminated. So child will be printed. Are you getting it now? So it entirely depends on the scenario. That means which process comes first. If parent process come first, then we will print parent child. If child process come first, then we will print child parent. Okay, so I hope I have made the point clear. So output of this program will be two outputs. Okay, so and it entirely depends on the scenario. So first possibility is child parent, second possibility is parent child. Okay, so two output means two things will be printed, child as well as parent. Okay, so two things will be printed. In which sequence I do not know. Are you getting it? So we will print two things, child as well as parent, but in which sequence I do not know. So it entirely depends on scenario, whether parent come first or child come first and so on. Okay, so I hope I have made the point clear to everybody. So yeah, you can take snapshot or something. I will jump to the next slide. Okay, let me put everything on the one slide so that you can copy paste it. Okay, yes, and while writing program, it's my request that you should match the brackets. So this bracket is matched by this main. Okay, so if bracket is this, else if bracket is this, and else bracket is this. Yes, everything is written fine. Okay, so now you can take snapshot. If you have any kind of difficulty, if you are facing any kind of problem, you can rewind the video and watch it again. I have explained it very clear cut manner. And sometimes many students face some kind of difficulty in execution and all. Please try to execute yourself. Okay, and it's your choice whether parent come first, child come first, and so on. So we can assume this thing. Okay, so I hope I have made the point clear to everybody. Okay, and if PID is equal to -1, then obviously it means that fork has not been executed properly. So that means what parent will be there, child will not be created. Okay, because parent has done fork system call. Now I have said it. Please try to rewind the video and watch it again. I have said PID is equal to fork. On successfully execution of the fork, your clone will be created in the main memory. That will be known as child. Now, if it is not executed successfully, okay, or it has not been executed properly, then what I will say, child has not been created. Okay, so PID is equal to -1, fork will be unsuccessful, and exit will be done. Okay, so I hope I have made the point clear to everybody. Okay, now you can take snapshot. I will jump to the next slide now. Okay, so now in this program, we were not able to guess what will be the output, either child parent or parent child. That was the biggest problem in this question. Another problem means what, this was just like that only, na? Because parent come first or child come first and so on. Okay, so now we want to fix the output. That means I want output to be child parent. Okay, I do not want parent child. I want to fix the output that is child parent. That means what? I want that child should be executed first. So now even if parent come first, I want to suspend it and I want to run child first. That is my aim. So now let me show you that program. Please take snapshot. I'm jumping to the next slide. Okay. So now what I want is I want output to be child parent. So let me show you. Okay. So again, I'm writing a program. So please see it carefully. Void main int PID and status. Status is a variable. Okay. Int PID status. And I'm writing PID is equal to fork. Okay. Same thing. Now if I will say if PID double is equal to 0, I will print child. Printf child. Okay, I'm not writing unnecessary that if PID double is equal to -1, I have written it. Na? I just want to explain that thing. I'm not doing proper programming and all. Okay, please do not think that, sir, what if fork is not successful? So you have not covered that case in your program and so on. Please do not think like that. I'm not teaching you programming and all. I am just teaching you the concept. So I have bypassed this thing. PID is equal to -1, fork unsuccessful, exit 1. Why? Because I'm assuming that fork is successful. Okay, that's why I'm assuming that, and I'm doing these kind of thing. You may argue, sir, how you can assume and all? Because I'm teaching you concept. I'm not teaching you programming and all. Okay, if I was teaching you programming, if this was a C language course, then obviously I will say I cannot assume all this kind of thing, and I have to cover all the possible cases, because in program we have to cover each and every case. Okay, but I'm not teaching you programming and all. That's why I'm bypassing that step. Anyway, I will tell you a very beautiful thing here. That's why I have bypassed. For each and everything which I'm doing, I have a hidden agenda in that. So please try to focus here. Do not focus on unnecessary things. Okay, printf child, and then we will say exit. Okay, so let us suppose I say exit 1. Yes, so it is done. And in else, I will write wait ampersand status. Okay, so call by reference. I think you already know ampersand status means reference variable we have done. So ampersand status. Okay, so directly indirectly we should say address of status has been taken. Okay, do not think about reference variable and all, because that is C++ case, and we are doing the program in C language. So address ampersand status means address of status. So wait system call. Now I'm going to show you wait. Okay, so for wait system call, we will pass variable by reference. You can think like that. Okay, so that's why I am saying that address of status has been given as an argument to wait system call. Okay. And after that, I will print parent. Printf parent, and then I will say exit. Say I have written exit 2. Okay, yeah. So let me put everything on one slide. Yes. So now you can check it out yourself. Brackets, this match, this match. Yeah, everything is fit and fine. Okay, now. So let me start it. So what we will say. So first line is in PID and status, we have defined two variables. So let me draw it in the main memory. This is the main memory. So let me take, this is the part for process P1, that is the parent process. When I have written this code now, so obviously when this code will start execution, so it will become a process. So let us suppose that process is P1. Okay. So now two variables are there, PID and status. So this is PID and this is status. PID and this is status. Okay. So now PID is equal to fork. So now I am assuming that fork is successful. So because fork is successful, so its clone will be created in the main memory. And let us suppose that is child process 1. So it also have PID and status. Two variables will be there. Okay, so now what I'm saying, so because fork system call has been successful, so PID variable for the child will contain value 0, and PID of the parent will contain PID of the child. So let us suppose child PID is say 10. So I will write here 10. Okay, I hope I have made the point clear. So I have written here 10. Okay, so now please see carefully. So now since now both are there, so both parent and child will be here itself. Why? Because PID, our work of PID has been completed. So now both parent and child will be here. So now it's your choice. So let us suppose parent came first. Let us suppose parent process came first. So parent process came first. So it will match PID is equal to 10. Both have same copy. I'm speaking again and again. Please do not get confused. Both parent and child will have same code as it is copied in the main memory. P1 and C1. Both will have same code. Okay. And both are stuck here itself. Okay. Yes. So yes. So now I am assuming that parent process came first. So when parent process came first, then it will say PID is equal to 0. No, it will not say, it is false because PID is 10. PID for the parent is 10 and I'm saying 10 is equal to 0. No. So it will come to the else part and it will execute the wait system call. So as soon as wait system, it will execute wait system call, immediately parent process will be suspended. Okay. So parent process will be suspended. Parent suspended. Till, if you try to remember, I have told you just few minutes back, parent process will be suspended till one of its child terminate. Till one of its child terminate, and by default, and by here we have only one child. Okay, so parent suspended till one of its child terminate. So here we have only, by chance we have only one child, no problem. So when it will terminate, parent process will be suspended. Okay, so parent is in suspend state now. Okay, so now since parent is in suspend state, so obviously now child will come into the picture. So when child will come into the picture, it will say PID is equal to 0. It will match. Okay, yes, PID is equal to 0. So it will print the child. Okay, so see this, please see carefully. Parent has been suspended. So parent has not executed this code. Parent will not be printed now because it has been suspended. So now child come into the picture and it will print the child. Okay, so output will be child. Okay, so I hope I have made the point clear. So output will be child and exit 1. So now I will tell you what do you mean by exit 1 and all. So what it will be done is this one will be copy pasted here. Okay, so status of the parent will contain this value 1. So status of the parent will contain the value 1. Are you getting it? So here if I have written exit 2, then status will contain exit 2. Status will contain value 2. Status variable, if I have written here exit 3, then status of parent will contain value 3 and all. Please try to focus here. This status variable of parent will get the value 1. I hope I have made the point clear to everybody. Okay, now. So now immediately, since now child has been terminated, so now parent will be resumed and it will print the parent. Okay, so it will print parent. Okay, yes. So final output is child parent, and now a parent will be also exit. I hope I have made the point clear. So what exactly we are doing? So I'm first is I have assumed that parent came first. Now since parent came first, so it will not execute this code and it will go to the else part and it will go to the suspend state. And when child will come, it will execute this code and it will exit. And when it exit, then this one will be copied to the status variable of the parent. Okay, and then parent will be resumed and it will print parent and it will be exited. I hope I have made the point clear. So this is output will be child parent. Now what if child came first? If child came first, obviously it will execute this thing. Okay, so printf child. Okay, and it will be exited. Okay, yes, and when parent will come, so obviously it will again parent will do the wait. But if now parent do the wait system call, then it will be suspended and no child can resume it. So in that scenario, what will be done? Whenever parent do wait system call and none of its child is executing, that means every child has been terminated. So in that scenario, wait system call will be ignored. Okay, so parent will not go to the wait state. Okay, so please try to focus here. Whenever wait has been done by parent and none of its child is in the you can say suspend none of the child is in none of the child is executing, so it will be ignored. Okay, so wait will be ignored and then obviously parent will print the parent and it will be exit. Okay, so final answer you should know child parent will come. So now please try to focus here this exit one. So this one is from the child na. So so this process is giving some value to the parent. Okay, so what do you mean by this? Exit one. So this one value was given by which process? Child process to the parent. Okay, so and these are the two different processes now. So directly indirectly I can say exit and exit and wait system call, these are one of the way of doing inter process communication between parent and child. This question has been asked in many competitive exam. Please try to focus here. So wait and exit system call are used for inter-process communication between parent and child. Okay, so child will exit system call will give some value and that value will be stored in the status variable for the wait. So directly indirectly the status variable of the parent will get some value from the child process. Please try to focus. From the child process, status variable of the parent is getting some value. So these are two different processes and still child is giving some value to the parent. So what do you mean by this? That means what? This is nothing but inter-process communication. So IPC, inter-process, one of the way of doing IPC, there are many ways of doing IPC and it is a basic course. I will not go into detail of IPC and all. So I will just tell you this thing that exit and wait system call, exit and wait system call are one of the way of doing IPC between P and C, parent and child. IPC means inter-process communication. Okay, this is one of the way of doing inter-process communication between parent and child. Okay, so I hope I have made the point clear to everybody. So exit and wait are one of the way of doing IPC between parent and child. Okay, please try to remember this thing. This is very, very important point. Okay. IPC mean inter-process communication. So you may argue with me, sir, what is the use and all? So since it is a basic course, I am not going into detail, but you can think like that. Status, na? So status is getting this value. So now you can, in parent process, you can write that if status is equal to 1, then child has been exited just because of such and such reason. Okay, so you can write exit 1 in the see, if part is for the child and else part is for the parent. So now in if part you can write many fancy codes and all, and you can write somewhere you can write exit 1, somewhere you can write exit 2, somewhere you can write exit 3, somewhere you can write exit 4 and so on. Are you getting it now? So in the child, this is for the child now. So in the child code you can write somewhere exit 1, somewhere you can write exit 2, somewhere you can write exit 3 and all. Okay, so whatever may be the case, exit means what? Child will be terminated. So whenever exit 1 will be executed, this entire code will be ignored by the compiler, or rather, I should not say ignored by the compiler. Child is terminated. That's it. Okay, so nothing will be executed after that. So exit 1 is done, nothing will be executed. So this one will be copy pasted in the status, and child will be over. Okay, similarly, if exit 1 has not been executed, then exit 2 will be executed. Obviously, there will be some if and else kind of things. So you know programming very well. I think you should know all these things. So you can write a very big fancy code writing exit 1, exit 2, exit 3, and so on. So and in the parent, you will write if status is equal to 1, then for such and such reason child terminated. If status is equal to 2, for such and such reason child terminated. If status is equal to 3, for such and such reason child has been terminated, and so on. Okay, so you can make very big and very beautiful and very fancy programs with the help of this exit and wait system call. Okay, so it is one of the way of inter-process communication. So now parent is getting the idea that why child terminated, okay, or for what reason child has terminated. So you can write the code and you can write exit 1, exit 2, exit 3, and so on. I hope I have made the point clear. Okay. So now again, very, very beautiful point is coming. So in interviews kind of thing, they ask such kind of question. We have if statement and we have else statement. So now they will ask, is there any way that both will be executed? You will say never. They are mutually exclusive. Only if will be executed or else will be executed. They cannot be executed. We cannot execute both. But if we want say like this, so they will say, I have written here printf abc. I have written here printf abc, and here I have written printf def. So now, is there any way to print abc def both? You will say, sir, it is never possible because here we have if and here we have else. If else, they are mutually exclusive. So either ABC will be printed or DF will be printed. We cannot print both. But they will ask you question like this: can you print ABC and DF both? So you will say, yes, I can do it with the help of for system call. So see this. So child has been printed and parent has also been printed. Both have been printed like this. In the previous example also you can think, but so explaining this thing, I have done this thing. Okay, in the previous example you may be get confusing because if and else, they were these three things now. So obviously these three are mutually exclusive, so even one of them will be executed, other will not be executed, like that. Okay, so now in the previous example we can say else if and else both are executed. Okay, yes, so I hope I have made the point clear. Please take snapshot. Please take snapshot of this. I will jump to the next slide now. Okay, now. Yes, so I'm jumping now. Yes, so if we see exact system call, I am not explaining because it is a very basic course. Okay, so you just I have just given you idea that whenever we will do exact system call, code will be replaced by this thing. Okay, yes, and if you want me, then I can show you a very small example. Okay, I will not dig deep into it. I will just show you a very small example. Okay, yeah. So let me show you. See, we can write void main. Okay, and we will write int PID status. PID is equal to fork if PID double is equal to 0 exact. See, I'm not going into syntax and all exact. There are actually lots of variations of exact system call. Okay, so I am writing exact LP. Okay, exact LP system call, and I will write here something, say bin ls. Okay, and the name is say ls and null. Actually, I have to explain a lot of things, and I'm not going into detail of all these things, so I will just give you a hint. Okay, exec lp, I will write bin ps and null. Okay, like this. So let me first match the brackets. Void main, this is over, this is over, this is over. Okay, so this is the code of child because PID is equal to 0 now. This is the code of parent. Okay, so when you can say this process has been started, sorry, void main we have written and all. So this process has been started. So let us label it as P1. So as soon as it has done fork, copy will be created here. Let us suppose this is child 1. So if PID is equal to 0, so child is creating this thing. So we have see, actually this is a Unix file system. This means root directory. In root directory we have a bin directory. In bin directory we have ls file. Okay, or I think you know na, ls command is to list the files which are present in the directory and all. PS command is for seeing whichever process are currently running, what are suspended and so on. All the information about processes can be seen by PS command. All the information regarding your files and all in the working in the current working directory or in some other directory which we give to the ls command and all. I think you already know these things. If you do not know, then you have to see these commands in Unix. Okay, so I can refer you a very beautiful book, Sumita Badas. Sumita Badas. This is a very, very beautiful book for Unix operating system, and it can clear lots and lots of your doubts regarding Unix. Okay, so anyway, I'm not going into details of all. I'm just telling you, ls command is used to just list the files. That's it. You can think like that. ls is for listing files. PS is for listing the processes which are running. That's it. Okay. Roughly, you can think like that. Okay. So now, since these are the commands, obviously they will be there will be some code, na. So that code is here. Okay. So now, since so what I will do, so process address space of the child, that will be replaced by this file. Okay, so what will be the code of the child? Same to same, copy pasted. This line by line has been copy pasted here, and this line by line is here also in the P1 also. So now this line by line was here, and now I will explain this. I will replace this entire code by this code. Okay, slash bin slash ls. Okay, yeah. So now this C1. So now it will. So I will name this process also. I have created a new process, so I will label it as L1. Why I'm saying it as a new process? Because now, since I have told you na, whenever exec system call is done, parent child relationship is broken. So now this is no longer a child. So I'm labeling it as a ls process. Okay. Null means I'm not giving any argument and all. I'm not going into details. I am just trying to give you a hint. That's it. If you are able to follow, it's okay. Otherwise, if you can simply ignore these things. Okay. Yes. And next is PS. So what parent will do? Parent process address space will be overwritten by this file. Okay. And the name of the process will be changed to PS. Okay. And the null means no argument is given to the PS and all. That's it. Okay. Yes. So I hope I have made the point clear to everybody. Yes, so that's it. Okay, so parent and child are now they are not no longer parent and child. So child code has been replaced by ls, parent code has been replaced by ps and all. Okay, so actually you may be thinking that it is not useful, but actually it is really very, very useful. Okay, so whenever you write any command in Unix and all, so these kind of things will be done. Okay, and anyway, I'm not going into detail because we are not doing Unix operating system. If you want to dig deep into it, you can study Sumita Bada's book. In that, you will find each and everything. Okay, how exactly all these things are done. Okay, that's it. Okay, that's it. So now we have done the programming. Okay, so now I will jump to the next slide and I will show you another very beautiful problem called producer consumer problem. Please take snapshot. I'm jumping to the next slide now. Okay. Yes, so now we are going to start producer consumer problem. Producer consumer problem. Okay. Yes, slowly I will dig deep into it. Okay, and let me tell you few more points before directly jumping to the code. Let me tell you some basic things about this problem, and then I will jump into it. Okay, let me take another slide. Okay, so what is producer consumer problem? Let me tell you something about it. Producer consumer problem, because if I straight away start the code, you will not be able to get what exactly we are doing. Okay, so we have a process called producer process, which is producing some items. Producer is producing some items. What is consumer? Consumer is consuming those items. Whatever producer is producing, consumer is consuming that, consuming those items. Okay. So producer is a process which is producing some item. Okay. Producer is a process. Process means some piece of code we have written which is producing something, and consumer is a process which is consuming those items. So consumer is also a process. Consumer is a process, producer is also a process. Producer is producing some item, consumer is consuming those items. So I hope I have made the point clear. So these are two processes. So what is the problem here? Let me show you the problem. Okay. So we have three cases. Okay. We have three cases. So the very first case is speed of consumer is more than producer. That means what? Producer is producing item slowly and consumer is consuming item at a very fast rate. Okay, or producer is producing slowly and consumer is consuming more fastly. That is, consumer speed is more than producer. So there is no problem at all. The only problem is a consumer will have to wait. And it has to wait also because I have assumed that consumer speed is more than producer. Okay, so obviously consumer will wait. Consumer will wait. Okay. Second case is speed of consumer and producer are same. Then also no problem. Producer is producing items and at the same rate consumer is consuming those items. No problem. None of them will wait. No problem. Okay. No one will wait. So again, here also no problem. Let me write it with another color. So there is in both the scenarios, no problem at all. So now what if producer speed is more than consumer? So producer is producing items at a very faster rate than the rate at which consumer can consume. So now we will have a problem, but consumer will be overwhelmed. Consumer will be overwhelmed. Overwhelmed means it will be obviously everything will go out of its head. Like for example, consider I am a producer and you are consumer. Producer means because I am speaking some words and I am trying to deliver lecture and all, and you are consumer and you are consuming that lecture or you are consuming those words which I am producing. So now if your speed is more than mine, so obviously you will wait. I am speaking slowly and your brain is working at a very fast rate. So no problem at all. You will wait for some time. Then I will speak. Then immediately you will process the data. Okay, sir, I said this thing and so on. So there is no problem. You will keep on waiting and because I'm speaking slowly. And if our speed is equal, I am speaking at some rate and you are understanding at some rate and both rates are same. So obviously none of us will wait. Everything will be completely fit and fine. This is one of the best case. But what if I am speaking at a very fast rate and you are not able to consume at that rate? Okay, I am delivering lecture at a very fast rate. So obviously you will be overwhelmed. Overwhelmed means now everything will go out of your head. Okay, you above your head, you will not be able to understand what I am speaking and all. So that is a very big problem. Okay, so now we so obviously what you will say is you obviously want to you can say consume the things at a faster rate, but you cannot do because your speed is less. So basically we want to prevent this overwhelming. Okay, so we do not want that the consumer will get overwhelmed and all, so we want to prevent this thing. So how we can prevent it? So take your example. What you will do? You will say, okay, sir is speaking at a very fast rate, but I'm not able to understand it. So better ways, I should write all the things in my notes, and slowly I will read that and I will get the idea. Okay, what sir has said and all. You may not be understanding, but you will keep on taking the notes. You will keep on writing the notes. Okay, so what are exactly those notes? These are nothing but just like a buffer. Okay, so directly and directly what I will say. So we want to prevent overwhelming of consumer. So for that, we will have a buffer or piece of memory. Okay, small piece of memory we will be having. Now what we will do, so producer will produce items in that buffer only. Producer will produce item and it will store that items in the buffer, and consumer will come according to its speed, and it will consume those items. Okay, so producer is producing items here, and consumer is coming and it is consuming those items from here. I think you have got it now. So producer is producing items and it is putting here in the buffer, and consumer is coming and it is consuming those items from this buffer. So now let me say something about the buffer. So now everything boils down to the buffer. Okay, what exactly is the buffer and all? I have told you it is piece of memory. So there are three possibilities. Okay, rather two possibility only. Why three? There are only two possibility. So I am talking about buffer size. Okay, so buffer size can be infinite or it can be finite. If buffer size is infinite, that means what? This size is very, very large. Okay, infinite. So obviously producer will keep on producing item, consumer will slowly keep on consuming item, and also there is no problem at all. Infinite, then no problem. No problem. But the biggest problem is how you will implement this infinite size buffer. That is not possible. Okay, not possible to implement. Theoretically it is possible, but not possible to implement. Practically it is not possible. Okay, theoretically possible, but practically impossible. So obviously buffer size is finite only. Memory is finite. Okay. Yes. So now problem will be there. What will be the problem? Because producer is producing item at a faster rate and consumer is consuming at a slower rate. So slowly buffer size will keep on growing. Okay, but since our buffer size is finite, so buffer size will say, let us suppose like this. So we have buffer till here. So whenever why buffer is growing? Because producer is producing item at a faster rate and consumer is consuming those item at a slower rate. So when this buffer will be full, so obviously producer will have to wait. Yes, so that is the problem. So I have to, so we have to do synchronization. So, and the basic thing again that will come into the picture when producer has produced item and it is accessing the buffer. Buffer is a shared resource. When producer is putting some items, consumer should not come and consume those items, because that will create unnecessary kind of problem. Let me tell you, because I will not dig deep into these things here because you will get confused. So basic thing is when buffer will be full, you should remember this thing. When buffer will be full, then producer will have to wait. Okay. So when buffer is full, in case of finite, what I will say, when buffer full, then producer has to wait. When buffer full, then producer has to wait. Producer has to wait. Okay. And basic thing, reason I will tell you afterwards, but the basic thing is when producer is accessing the buffer, then consumer should not access the buffer, or rather I should say both producer and consumer should not access buffer at the same time. Okay, they should not access the buffer at the same time. They should not access buffer at same time because it may create problem. Okay, what are the problems and all? I will tell you. Don't worry. Yes. So finally, producer consumer problem boils down to the case there is no problem here, there is no problem here, so it is not producer consumer problem. This is a producer consumer problem. So that means what? A producer consumer problem is saying when producer speed is more than consumer, so we need a buffer, and producer will keep on producing item in the buffer and consumer will keep on consuming those items from the buffer, and they should not access the buffer at the same time. And when buffer is full, then producer should stop producing the items. Okay, this is the basic scenario of producer consumer problem. Since size of the buffer is limited, or we are taking finite size, so we call it as bounded buffer problem also. We call it as bounded buffer problem. Okay. Yes. So now please take snapshot. I will jump to the next slide and I will tell you the code. Okay. How we will write code, how we have written code and all. Please take snapshot. Okay, so I think lecture has become lengthy. So we will study this code in the next class. Okay, so in the next class, we will study the code of producer consumer problem, and we will try to think about solution of this also. Okay, what is the solution of producer consumer problem and all. So we will study that thing in the next class. Okay, yes. Thank you so much. Bye-bye.